Ladies and gentlemen, welcome to the second and final video for section 3 of chapter 4 in your geometry book, covering congruent triangles, how the word congruent applies to polygons in general, but in this case triangles. We do have a new theorem to introduce in this section, that is the Triangle Third Angle Theorem. Okay, the Triangle Third Angle Theorem is a relatively straightforward theorem. I'm going to write it out in words, and then I'm going to write it out in symbols. It says, if two angles in one triangle are congruent to two angles in a second triangle, then the third angle in each triangle must be congruent. Now in this picture below, you'll notice that we have an if and a then. The if would be the given here. So if we already have that marked, if angle A is congruent to angle D and angle B is congruent to angle E. In other words, we have two sets of congruent angles. That means what this theorem is stating is that angle C must be congruent to angle F. This third angle has to be congruent if the other two are. Now we're going to prove that theorem next in this video. Please note that when you prove a theorem, you're not allowed to use that theorem to prove it. Okay? We're trying to prove it so that we can use it to prove other theorems. So before we can use it in proofs, we have to prove it. So to do that, we're going to carry out the following proof. Given in this picture that angle A is congruent to angle D and angle B is congruent to angle E, we are trying to prove that angle C is congruent to angle F. So that's all by itself here on this page. And then on the next page of the notes, you'll notice there's a fill-in-the-blank proof. So I am going to turn the page here on the screen, and you won't be able to see this picture anymore. I may flip back and forth a little bit as time goes. Okay? So here we go. We start every proof the exact same way, that is by relisting the givens. So we take our givens, which were A is congruent to D and B is congruent to E, those angle congruent statements, and we rewrite them as step 1 in our proof. Reason is that because that's given. Now this proof is algebra based, which means we're probably going to need to use things like subtraction, substitution, and those things are not allowed to be used on congruent statements. So our very first statement should be to take those congruent statements and rewrite them as equations. If A is congruent to D, then the measure of angle A must equal the measure of angle D. If angle B is congruent to angle BE, then the measure of angle B has to equal the measure of angle E. So we can use what's called the definition of congruence to switch those from congruent statements into equations. Now we can use all of our algebra properties on those angles. We can substitute, we can add, subtract, multiply, divide. We can do a lot more things with equality than we can with congruence. Statement 3 is based on the picture. If we look in the picture, angle A, angle B, and angle C form a triangle. If they form a triangle, those three angles have to add up to 180 degrees. Same thing can be said for D, E, and F. So this statement here in step 3 that says measure of angle A plus the measure of angle B plus the measure of angle C is 180, that's because A, B, and C form a triangle. D, E, and F add to 180 for the same reason. This is the triangle angle sum theorem, which says the sum of the angles in any triangle must be 180 degrees. So we've got a total of 4 equations to work with. We are trying to accomplish, we're trying to basically get to the point where we state that C and F are congruent angles. Okay? That's what we're trying to prove, is that C is congruent to F. So we need to manipulate those 4 equations so that we can eventually say the measure of angle C is equal to the measure of angle F. If we can say that, then we can switch it back to congruence. So here's how that is done. We have 4 equations. We are going to take this measure of angle D plus the measure of angle E plus the measure of angle F. That part that I just highlighted is equal to 180 degrees. That means that I can replace 180 degrees in the first equation with that. So I'm taking this green and I'm putting it in for 180 degrees. That gives me the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle D plus the measure of angle E plus the measure of angle F. Because I've substituted this into the right side, which means this is equal to this. That is a substitution property. Now on the next step, what we're going to do is we're going to use our equations from step 2. If you notice, the only difference between 4 and 5 is that D turns into A and E turns into B. The reason for that is we're substituting the measure of angle A in for the measure of angle D, and the measure of angle B is going to be substituted in for the measure of angle E. This is also substitution property. We're carrying out two substitutions at the same time to change the right side of the equation to have a measure of angle A and a measure of angle B as well. Now that we have A and B on both sides, we can get rid of them. Notice what that would leave. That would leave C and F as being congruent to or equal to each other, which is where we're trying to get. Now subtraction does take 2 steps in a proof. In step 6, we're going to show that subtraction. Now, normally we would write all of this on one line, but that is an extremely long line of text. So we're going to take a slightly more algebraic setup here. We are going to be subtracting the measure of angle A from each side and the measure of angle B from each side. So in a proof, first we have to show that subtraction, which I'm doing now. See how we're showing subtracting A and B from each side of the equation. That step gets named the subtraction property. And then the next step would be to actually carry out that subtraction, which would mean that these would drop out, leaving the measure of angle C equals the measure of angle F. When we do that, that is the substitution property, but we're not using it to substitute. We're using it to simplify. So we've been writing substitution simplify in our proofs. Now, what we've done is we've stated that angle C is equal to angle F. If the measure of angle C is equal to the measure of angle F, that is what congruence means. So we can convert that statement back into a congruent statement and state that angle C is congruent to angle F, which would complete this proof, proving it for all triangles, meaning that we can now use the third angle theorem anytime we want to find a missing angle. Okay, so now that we've carried out the proof of the third angle theorem, we're going to do some algebra-based examples and call it a day. Here is an algebra-based problem where we are asked to find the measure of angle A and the value of y. And if you notice, we've got some markings in this picture, okay? We have E is being marked as being congruent to B, and C is congruent as being marked as being congruent to F. That means 2 of the 3 angles are congruent. If 2 of the 3 angles are congruent, that means angle A has to be congruent to angle D by our third angle theorem. Okay, the one we just proved, which means that the measure of angle A is equal to the measure of angle D by definition of congruence, which means we can set up the equation y plus 10 must equal 2y minus 40. Okay? So we can solve that equation, and that gives us the value of y. We subtract y from each side, and we add 40 to each side. And we get that 50 is equal to y. Now don't be that guy that thinks you're done, because you're not. You've only provided half the answer so far. But if y is 50, then we can use this to find the measure of angle A. If y is 50, then the measure of angle A is y plus 10, or 50 plus 10, meaning that the measure of angle A is 60 degrees. Once again, the next problem is one that you could pause the video and try it on your own. You may not use the third angle theorem to do it. There's lots of theorems we could use. There's a couple different ways to do the next example. So please pause the video and try the next example and see what you get, and then watch my solution and see if I get the same thing. Remember, if we get the same solution but we do it 2 different ways, that's fine. That's geometry. There are multiple ways to do most problems in geometry. Okay? So pause the video, try the next example. So here's the next example. Hopefully you are resuming the video here. You've paused it and tried it. I will say that when I look at this problem, it can be done with third angle theorem, but it doesn't have to be done with third angle theorem. In fact, we don't even need this part of the picture at all, in theory, because we have enough information in that top triangle. We have that the measure of angle A is a 90-degree angle, and we have that this angle down here, AEB, is 41 degrees. So these three angles form a triangle, meaning that 2x plus 9 plus 90 plus 41 must be 180 degrees. That is our triangle angle sum theorem. It doesn't matter which theorem you use to set up an equation to solve for x, as long as you use a proper equation, a correct equation. Now the parentheses are really kind of unnecessary. Our next step is to add up our like terms, which would give us 2x plus, and then 9 plus 90 plus 41 is 140 equals 180. We would then subtract 140 from each side to give us 2x equals 40. And then we would divide by 2 to give us x equals 20. Quick check to make sure we've actually answered the question. We were only asked to find the value of x, so we have completed the problem. Thank you very much for your time. I look forward to teaching you your next lesson via video lesson. Thank you.